So previous video we have seen what are the different types of welding defects, and we have discussed the difference between defects and discontinuities. Then we have seen different types of welding defects and what are the causes for the defects and how we can address those causes. So today we'll talk about weld inspection and testing. So it is a fairly simple topic. Weld inspection and testing, it refers to the process of verifying whether the welding which has been performed, whether it is as per the requirement or not. So there is a minute difference between weld inspection and weld testing. Inspection is the general observation of the weld, whatever welding has been done. Inspection is a very general thing. You just visually, most of the times you just visually inspect it, and through visual inspection you can find out whether the weld is proper or not. You can find out whether there are discontinuities in the weld, or whether a lot of spatter has happened, or whether the bead width, the deposited bead width is uniform or not. These kind of things through visually you can find out. So inspection is the first step. First you just visually inspect it, and from that visual inspection you find out whether the welding is as per the requirement. Of course, after inspection always you have to perform some testing. Inspection has to be done first, but it is not the last step. You just cannot visually see a weld and say okay, the welding is correct or it is as per requirement. Visually you have to check first. If it is correct, then you have to go for testing. Testing is a more specific and more quantitative term. Testing involves setting up the welded specimen in a particular configuration and then loading it to observe the mechanical properties. We set it up and then we put some mechanical loads, and then we find out how it is performing, what are the mechanical properties it is exhibiting, and so on. Weld testing is basically of two types: destructive test and non-destructive test. As I have told in the final few minutes of the previous video, that testing is of two types: destructive testing and non-destructive testing. Destructive testing, we perform it in a manner so that the weld is destroyed, it is damaged. But non-destructive testing, it is done without damaging the weld. We'll talk about it later. So now we'll talk about visual inspection. Visual inspection is the simplest and cheapest of all the techniques. In this method, the weld is inspected visually by an authorized person. So sometimes a special equipment is also used. So as you can see over here, a person is checking that T joint. He is checking using a handheld device, not exactly a device. You can see sort of an attachment is there. So it is moved horizontally throughout the weld, and wherever some discontinuity is there, we get some deflection in angle. So this angle can be measured, and then we can determine whether the welding is okay or not. Similarly, we have fillet weld gauges, which checks the convexity of the weld bead, whether the convexity is as per the requirement or not. Then we have misalignment gauges. Here you can see two specimens are there, and before welding, while setting it up, we can see whether the misalignment is present or not. Misalignment gauges are there. Most of the times misalignment gauges are not that much used in welding. Visual inspection, the advantages are it is very simple and very cheap. It is very fast also, just visually you can do it. One of the limitations of visual inspection is the person who is performing the visual inspection, he has to be an expert in the field. He has to have a lot of experience. He should know what are the requirements from the weld, and how to check, what to check. These things he should know. Disadvantages of visual inspection is we cannot find out the micro-sized cracks or subsurface defects because they are not visually identifiable. We cannot see it with naked eyes, so we cannot find those things out. So visual inspection, you can see this is an example of underfill. Just by naked eye we can observe it. Similarly, inspecting a welded pipe, this is a circular cross section, so they are using a different device here. It is moved over it is moved throughout the weld, and the deflection is noted in angle, and then you can find out whether the deflection is exceeding the acceptable limits or within the acceptable limits. Here it is an example of a very poor weld. A T joint, L-shaped joint has been formed, corner joint has been formed, but it has a lot of spatter is there, and also discontinuity is present in this. Next up we have destructive testing. So destructive testing are class of tests in which the welded joint is loaded in a manner such that it undergoes permanent deformation. Destructive testing, it is done to find out the mechanical properties, whether the welding is performing well under the loading conditions or not. But the limitation of destructive testing is once you have tested a specimen, it cannot be used further. So destructive testing, the most common form of destructive testing is bend test. So schematic for bend test is shown over here. This is the longitudinal direction of the welding, and after loading it bends in the direction as shown in the figure. So, bend testing is basically of two types: free bend test and 3-point bend test. So free bend test, for example, for a lap joint, free bend test, the welded specimen is kept in a vertical configuration inside a universal testing machine, and then the compressive loads are applied. So the idea behind free bend testing is you apply compressive loads so that bending stresses are developed at the joint, and then you find out at how much load, how much deformation or how much damage is being caused to the welded specimen. If it is within the acceptable limits, the welding is okay. If it is not, then it is discarded. So first one is free bend test. Second is the most common approach is 3-point bend test. 3-point bend test, there are 3 points of contact. So contact number 1, contact number 2 are the locations on which the welded specimen is supported, and from the third point of contact we apply the load. So it can be classified as root bend, face bend and side bend depending upon the location on which the bending stresses are developed. For example, in the first configuration, if the load is applied from top, the root will be bending, so we call it as root bend. Similarly, if we keep the welded specimen in inverted position and we apply the load from here, the face will bend, we call it as face bend test. Similarly, in this configuration, side will bend. If the load is applied, side will bend, we call it as side bend test. So these are the destructive methods. Next up, we have non-destructive testing. The idea behind destructive testing is you perform the destructive testing for one specimen, and then you say that the batch of that welding is okay. For example, you have performed 10 weldings, so you take one out of that 10 and you test it, and then say if that joint is okay, then rest of all the joints will be okay. Or if that joint is not okay, then all the 10 joints have to be discarded. So this is the idea behind destructive testing. But the problem with destructive testing is once the test has been conducted, that particular part is discarded. We cannot use it further. So if we are doing some expensive welding process or the material is very expensive, then destructive testing is not feasible. Second thing, the idea that if 1 out of 10 is correct, then rest 9 are also correct. This idea is not a very good thing. You cannot claim it for critical applications, critical components, you cannot claim it. So we came up with non-destructive testing, which is known as NDT. NDT are a class of tests in which the joint which is being tested is not damaged, and after the testing we can use it. So we can test a joint, and if it is okay, then we can use it directly into the application. That okay, I have tested it, it is okay, now I'm using it for the application. So first in this is dye penetrant test, which is fairly simple. We take the welded specimen on which suppose a crack is present. We apply a wetting liquid on top of it. Wetting liquid have high surface wetting characteristic is there. They flow inside the crack. Then we remove the excess wetting liquid. Then we apply a developer. So the developer pulls out the liquid from the crack. So the cracks which are not visible, the micro cracks which are not visible to the naked eyes, now we can easily visualize it. We can find out how many cracks are there or whether cracks are present or not. So this is called as dye penetrant test. It is cheap and it is faster compared to destructive testing. There is no setup time, no loading time and all. So this is a cheap and fast method. Is magnetic particle inspection. Magnetic particle inspection based on the principle that if any discontinuity or defects are present inside the welded joint, the magnetic lines, the flow of the magnetic lines will be disrupted. The limitation of this is the material which is to be tested has to be ferromagnetic. So what we do, we take iron particle, iron powder which are magnetic, we sprinkle it on top of the joint which is to be tested, then we magnetize the joint. So after the magnetization, wherever cracks are present, the iron particle tends to cluster around the crack. Now depending upon the number of cracks, if there are more number of cracks, there will be more number of clusters, and if the size of the crack is high, then the size of the cluster will also be high. So this way we can find out how many defects or how many discontinuities are present and what is the size of that defect. So the defects or discontinuities may be cracks, it may be porosity which is present, subsurface defects which is present, or blowholes, whatever is there. It is quite fast. It is faster than dye penetrant test, but it is only possible for ferromagnetic materials. Next up, we have radiographic inspection. So radiographic inspection is based on the ability of short wavelength EM radiations to penetrate various materials. So we know there is an electromagnetic spectrum, and depending upon the wavelength, different region of the EM spectrum is defined. So the short wavelength spectrum, for example, the gamma rays, the X-rays, they can penetrate throughout various materials. And then depending upon the thickness of the specimen which is under testing, it forms a particular type of pattern. Now if there are no defects or discontinuities inside the joint, a particular form of pattern will be formed. But if some defects or discontinuities is present inside the welded joint, a different type of pattern will be formed. So the nature of pattern which is formed after the radiation has passed through the specimen, it is an indication of the type and amount of defects present inside the joint. The method is highly accurate, but it is expensive, and it has major safety concerns. So the method is highly accurate. It can give even with integrated joints, even with very novel materials, we can find out whether any defects or discontinuities are present. But the only problem is it has a lot of safety concerns. For example, if you are introducing gamma rays onto a substrate, you have to be very careful that you do not introduce the operator to the gamma rays. If the gamma rays falls on the operator, then his safety is compromised. So you could have seen a lot of videos on this. You could have seen the Chernobyl series also. So gamma radiation is very harmful. It can cut through tissues and all. So for radiographic inspection, it is kept for highly critical applications, very complicated joints, and for those cases it is used. It is very costly also. The last type of NDT is ultrasonic inspection. Ultrasonic inspection is based on the principle that sound waves travel at constant velocities through any medium. So by measuring the time which is taken for a sound wave to travel inside the medium, we can find out how much distance the wave has traveled. For example, suppose this is the plate which is to be tested. This is the welded joint which is to be tested, whether any cracks are present or not. So we input a high frequency sound wave. So if there are no discontinuities, it will strike the other end of the plate and then it will come back. So this time lag between introduction of the high frequency sound wave and then receiving the signal, we can note down this time. This time will correspond to the thickness, because it will traverse this thickness and then again it will traverse back. But even if discontinuities are present, the time taken for receiving the sound wave, it will be lesser. Now by measuring the time, we can find out how much is the distance, between the top surface of the joint and the crack, and then we can find out this this time lag for throughout the length. So that way we can find out that this region, particular time, suppose T normal is taken, so this region is normal. This region, the time taken is less than T normal, so some cracks are present. Now depending upon the time, we can find out how much is the length of the crack, how much is the depth of the crack, and so on. So advantages of ultrasonic testing is it is highly sensitive, it has greater accuracy, it is non-hazardous, there are no chances of radiation exposure or anything. Disadvantages, it has to be manual operation, so very carefully you have to do. Manual errors may come up, as I have told before also. Human being can create lot of errors, so those things have to be accounted for. Experienced personnel is required, training has to be given, proper training has to be given. But the most important thing is the joint which is to be tested, it has to be free from any impurities. If the surface itself is having some rusting or impurities or some scales or dirt or grease, then the calculation or the observation will not be proper. So this is all about weld testing and inspection. If any doubts are there, these are my contact details, you can ask me. So stay healthy, stay safe.